So I realize, it's been a while and we haven't been really getting pictures of my cat. So there he is. There's my cat. You can see the blankets moving. That's as much of Theodore as you're probably going to get today. So, let's do some problems that have a little bit harder setup. And by some problems, I mean one problem. Some of these problems are pretty straightforward, right? And a lot of these, if we organize our data in a table, our constraints kind of just look like the table, right? Well, sometimes that's not the case. Let's get into this example. A distribution company needs to ship products from its 2 warehouses to 3 retailers. 2 warehouses full of stuff needs to go to 3 different retailers. Warehouse A has 1,000 products in stock. That's not written in our table. So let's say that it has 1,000 products in stock. Warehouse B has 1,200. Retailer 1 needs 700. Retailer 2 needs 500. Retailer 3 needs 600. The cost to ship a product from each warehouse is shown below. Okay, so this table is costs from warehouse to retailer. Find the number of products a company should ship from, so number of products from each warehouse to each retailer to minimize shipping costs. Also, this is like the most generic linear programming problem too. This is essentially what linear program was invented for. In the 20th century, basically it was mostly the US military that we are taught about anyway. I'm sure this is going on in other places, but in the United States, we one of the guys who was doing it was commissioned by the US military to essentially optimize like troop allocations, supply allocations, and all that stuff. That's really what one of the things that got this started, at least in the US. I don't know about other countries. So, what are our variables? This is the tricky part. What is it asking? Find the number of products the company should ship from each warehouse to each retailer. So, right, we're going to ship some number from warehouse A to each retailer. And those could be different numbers. So 3 variables already. And we're going to ship some number from warehouse B to each retailer. That's 3 more numbers. So we've got 6 variables, right? We have to decide for every warehouse, how much does each warehouse send to each retailer? 6 variables here. A couple of ways that you could name these. You don't want to do X, Y, Z, you're going to run out of letters. The very natural choice is to do A1, A1, A2, A3, and then B1, B2, B3. So A1 will just be the units shipped from warehouse A to retailer 1. And then A2 will be shipped from warehouse A to retail 2, and then shipped from warehouse A to retail 3, and so on, right? This is warehouse B to retail 1, warehouse B to retail 2, and warehouse B to retail 3. Okay. We want to minimize the costs. We're minimizing the costs. What are the costs? Well, these are the costs. These 6 numbers are the cost. It's 3, we don't know what the cost is. I doubt maybe it's $3 per unit. We don't know how big these units are. $3 to ship something from warehouse A to retail 1. $5 from warehouse A to retail 2. $6 for each one in warehouse A to retail 3. Then 4 for B1, 7 for B2, and 5 for B3. 6 variables. Woo! You're glad we're not doing this one by hand. All right, but it's still a lot of writing. All right, what are the requirements here? Well, we have the requirements written by the table. Warehouse A only has 1,000. Okay, so let's write those down, right? A has 1,000. That's going to be a requirement. B has 1,200. That's going to be a requirement. Retailer 1 needs 700. Retail 2 needs 500. Retail 3 needs 600. Whew. And we need non-negativity constraints. Lots of requirements here. All right, and this is really starting to look more like a regular linear program instead of like a classroom linear program. Okay, and in reality, these usually aren't written down by hand. They usually are organized in some kind of matrix. Okay, which is why a lot of this data is presented in tables, because tables are essentially matrices with labels. Anyway, so if warehouse A only has 1,000 units, what does that mean? Well, that means that the total units shipped from warehouse A to any of the retailers can't be more than 1,000. So from warehouse A to 1, from warehouse A to 2, from warehouse A to 3, that can't be more than 1,000. Usually we line up all of our variables when we write these equations, but to save space, I'm not going to line them up. Right, so right now A's are lined up mostly, but when I start, I didn't leave space for the B's. That's okay. All right, warehouse B only has 1,200. That's going to look very similar. B1 plus B2 plus B3. Right, the total amount we're shipping out of warehouse B can equal more than 1,200. Retailer 1 needs 700. Let's make sure they have at least 700. Retail 1, well, they're getting it from warehouse A, and they're getting it from warehouse B. That needs to be at least 700. That's the only way that retailer 1's getting stuff. How many stuff is they getting from warehouse 1 or A, and how many are they getting from warehouse B? And very similar for the next two, right? That's going to be, whoa. A2 plus B2 has to be at least 500. A3 plus B3 has to be at least 600. And all of these letters, I'm going to use a shorthand here. All of these letters have to be non-negative. And there we have a nice, beautiful linear program. Woo! One of the nice things about naming our variables this way is that these constraints actually look like they make sense. Right? This first constraint is the requirement for warehouse A. It just got a bunch of A stuff. This one, requirements for warehouse B, got a bunch of B stuff. Requirements for the first retailer has a bunch of 1s as the subscripts. 2s as the subscripts, so it like kind of looks really nice that we named it this way. All right, so this is our linear program. See if we can type this into the calculator. See if there's room to answer the question. Oh, there's totally room. All right, so to make this go a little faster, I'm going to drag this over to my second monitor and just type it in, hopefully quickly. We're trying to minimize the cost, which is 3A. Have we done subscripts before? Not in this program, I think. I think it's okay if it uses subscripts here. I don't see any comment on subscripts, but... Oh, I was hoping the example would have it. Let's find out. I don't think it says anything with that. Yeah, we'll find out. All right, so we're trying to minimize cost, which is 3A1, 5A2, 6A3, 4B1, plus 7B2, plus 5B3. We'll use underscores for the subscripts. Subject to the constraints, A1 plus A2 plus A3 less than or equal to 1,000. B1 plus B2 plus B3 less than or equal to 1200. You might be able to get away with this without the underscores too. A1 plus B1 at least 700. A2 plus B2 at least 500. A3 plus B3 at least 600. And then A1 greater than or equal to 0. A2 greater than or equal to 0. A3 greater than or equal to 0. B1 greater than or equal to 0. It's funny because it feels really tedious to type this all in, but doing it by hand would make it way, 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 way worse. See if it likes these. Nope, it doesn't like that. All right, so I wonder if it likes it without the subscripts. I don't know if it's going to like this any better. Let's see it. Probably not. Oh, it does like it, actually. All right, so don't use the subscripts like that. Type it in like this. We'll get the cost is 7,800. Let's bring that back over. Oh, there we are. Cost is 7,800. A1 500. So is A2. A3 is 0. And then the B's are 200, 0, and 600. So again, before we even write our answer, this is not black, this is brown, isn't it? Before we write our answer, let's make a check that this makes sense. The total cost is 7,800. Yeah, we could check that. I'm not going to check that part, but the other ones are easily checked, right? Warehouse A only has 1,000 units. Look, we're sending 1,000 out of warehouse A. Warehouse B only has 1,200. We're only sending 800 out from warehouse B. That's fine. We just couldn't exceed 1,200 from warehouse B. Is retailer 1 getting enough? They should have 700. They're getting 700. Warehouse B needs 500. They're getting 500. C needs 600. They're getting 600. Great. Answer makes sense. All right, so the minimum cost. 7,800. And again, when you answer your question, you shouldn't use variables. We created the variables to help us solve the problem. Your final answer, though, should not have the variables in it if you created the variables. The minimum cost is $7,800. And we ship 500 units from A for retailer 1. 500 from A to 2. 200 from B to 2. And 600 from B to 3. You don't have to specify the zeros here. Let me know if you have any questions. Have a great rest of your day. Hope you enjoyed this problem. Bye-bye. Oh, quick side note. I don't have any problems from the homework because the homework is basically just more of these, and we've done just 5 of these in all these videos. So I don't think there was anything new from the homework that I wanted to cover. So this is the last video for this section. But yeah, you can always let me know if you have any questions. Bye-bye.